Alright, so here we are today for discussing section 4.6. So this is pretty much similar to section 4.5 where we discussed the sine and cosine function and their graphs. So here we'll be just talking about the similar variations of graphs, but this time the functions are the other four. So basically the tangent, cotangent, cosec and the sec functions and their graphs. So we'll first look at their basic original graph, and then we'll talk about their variations. Now, as you remember that the tangent functions are undefined at some point, especially at every 90. So what happens is, in case of the tangent, if you just take the tangent graph, you will see that the more you go towards the positive or the negative direction of x, the values of the tangent are exponentially rising. If you look at the values here, look at this. The tangent 45 is 1. Compared to that, tangent 89 degree is 57.3. So compared to that, you see how exponentially is increasing. It becomes undefined. Undefined means it getting higher, and undefined means it goes all the way to. So this line does never basically intersect this y is undefined.
So that's why we always stop here, because we just assume that it goes all the way to the infinity, and similar is on the negative side, it goes all the way to the infinity. Okay. So that's how the tangent is defined, because we know that at some point the tangent curves are not defined. So here we try to show you different ranges. So basically what you need to do is, when you will be looking at the variations of the tangent, for an example here, we still have the similar generic equation for tangent, just like how we tried yesterday. So A stands for the absolute value, which is our amplitude, and so but little bit different here is because, for an example here, so whatever the A is, that will be the y coordinate. So here, for an example, how we can do it is, so let's say if we just feed any tangent equation to that formula, then what we do is we first find two consecutive asymptotes. Asymptotes means two consecutive points of x where the y is infinity. So we first find those by finding an interval containing one period like this, because we'll first tell that this is going to be the interval which must be less than bx minus c and also greater than less than pi by 2, for an example, and also greater than negative pi by 2. And for that interval, we are going to define that that these are the two pair of intervals for which y becomes undefined. So for an example, for this point y is undefined, right? And for this point y is undefined. So these are basically those two asymptotes. They are called asymptotes because on those 2 points the y's are undefined. In such cases we call those points asymptotes, because on those points we don't know exactly what will be the value of the function. Okay. So there are plenty of discussion about asymptotes. I'm just trying to give you just like the headlines of the asymptotes, that why we call it asymptotes. So basically we'll be finding a pair of consecutive asymptotes which occur at these 2 points. Okay. So what we are going to do is we'll assume that bx minus c equals to negative pi by 2 and bx minus c equal to this. So this is how we'll basically find two asymptotes, and then we'll identify an x-intercept and midway between consecutive asymptotes. So basically this is the midway between two asymptotes, and find the points on the graph
1 over 4 and 1 over 3 of the way between consecutive asymptotes, and these points have y coordinates a minus a and plus a. So for an example here, look at this. This is the y coordinates, negative a and y coordinates. So this is basically if you just take this as an interval, and if you divide it into 4 equal, let's say quarter. So this is your first quarter, this is your second quarter, and this is going to be your third quarter. So this dot will be basically aligned with the first quarter line, and the middle intersection will be on the second quarter line, and this dot will be on the third quarter line. So as long as you know these, so you'll be able to divide it into 4, and then you will know exactly where the negative a and positive a will be. Basically, you will know the a from the equation, but what I'm saying is, for an example, you know the a is 3, for an example, from the equation. So what you are going to do is, you'll first draw x and y. So you know, for an example, this is 3. So let's say, let's take 3 here. Let's say this is 1, 2, 3, and that's negative 1, negative 2, negative 3. So you will know that, so along the x coordinate, you know there is, let's say this is pi by 2 and this is negative pi by 2. So you know on those 2 points, your function will be undefined. Okay, so you will divide this whole thing into 4. So this is going to be the 4 part. Since this is negative pi by 2 and this is positive pi by 2, this is going to be pi by 4, this is going to be negative pi by 4. Now, if you take a point here, which is basically for 3 and negative pi by 4, so which is basically negative pi by 4 comma 3, and take another point here, it will be in the third quarter here. So then you will know that the line will be passing like this.
And remember, it will be going closer. I probably have not drawn it properly here. It should not be that aligned. It should be something like this, because this is a vertical line. This is going to be another vertical line, and this line will never touch it or go all the way. So it's important to identify these 2 points basically. Once you know these 2 points, you will probably pretty much guess how the line will look like. And to identify these points, all you need to do is, you will know the a from the tangent. So you will know exactly how the a will look like. So from the a and pi by 4, you will know this point. I'm saying negative a, negative pi by 4, negative a, and positive pi by 4, positive a. You will be able to find 2 different points, and then you will be able to draw the tangent graph. So all you are doing is, first you will find 2 consecutive asymptotes by finding an interval. But remember, that interval will be always, in most of the cases, it will be negative pi by 2 and positive pi by 2. And then you will also, let's see. So basically, what you are doing here is, if you have some c here, okay, when you adjust it, let's say you have some b or c. If you do little math here, you will exactly know what will be the x, right? In general, in the original graph, original tangent, this is pi by 2. That's why I have drawn pi by 2 here. But when you have some b or some c, you can do some math and you will know what exactly the x will be. For an example, let me show you an example. Let's say I take a small simple number. Let's say I take 3x minus 4. If you make it equal to pi by 2, you can just solve it for x, right? And then by solving it for x, you might get pi by 2 plus 4 divided by 3. Whatever it is, just if you do the math. And that will be here, basically. Okay, let's do an example and see how we understand it. I think let's see.
Let's try this one. Now here, first of all, what is the value of A? 1. Remember, the A is an absolute value here, so which is, we take the absolute value of A, which is 1 here. And what is B? B is 2. How about C? C is 0, right? C is 0. So how we proceed? We first will find, so let's try to match the equation first. Let's write the equation. Y equals to minus tangent 2x. Now from here, what do we know? We know that A is minus 3, but the absolute A is 3. We know that B is 2. Now, how we start? We will first write, this is what we need to write, bx minus c equals to pi by 2. We have to find two asymptotes, right? We'll first do this. Now here, for this equation, bx minus c is basically your 2x because there is no c, right? There is no c. C is 0 basically. So you just write 2x equals to pi by 2. So what will be the x? Pi by 4, right? Any doubt? And then we will also do another step where we will write bx minus c equals to, that's for the negative side, that negative pi by 2. We'll make this equal, and then we know that the bx minus c is 2x for this equation, so this is 2x equals to negative pi by 2, so x equals to negative pi over negative 4. Now these two are going to be two asymptotes for our graph. Now let's draw the asymptotes here. Let's draw the asymptotes for the graph first. Now let's say this is our graph, and let's draw the asymptotes here. The first asymptote will be here. Let's say this is pi by 4, and the other one is, let me check, is it pi by 4 bx minus c? Yeah. And the other asymptote is negative pi by 4. Now you already got the asymptote. Let's draw two vertical lines here, because let's draw two vertical.
Now, okay, so this is going to be the center. Now what is A here? 3. So let's cut 3 from here. Let's cut negative 3 from here. And let's divide this into 4 quarters. If we do this, how much it would be? It would be negative pi by 8. This will be, I'm just taking the half from here because this is 0 and this is negative pi by 4. So if you just take the half, because you know when you're trying to divide the whole thing into 4 parts, you're basically trying to divide it into 2, this into 2. So this is going to be pi by 8. And then we will get some points from there. But remember, there is a negative sign. We'll have to do the reflection at the end. We'll do that later. Just forget about the reflection from now. Forget about the reflection. So what we are doing is, how do I get A equals to 3? A is just 1. I probably got it from the previous question. So A is 1 here, right? So it's just 1. So this point will be here, which is because of 1. So this is going to be negative 1, oh, not negative 1, negative pi by 8, negative 1. This pi by 8 is because of this, and this negative 1 is coming from the value of A.
and we'll take another point here which will be pi by 8 comma 1. This one is again for the a, because we just take positive a and negative a, these 2 points. Now since you have these 2 points in the center, we are now ready to draw the curve. We probably will add it first like this, and then we'll guess the curve. Maybe we guess the curve like. Now remember, the reflection is not done yet. This is what we have without the reflection. Because of the negative sign, you see that there is a negative sign. So because of the negative sign, everything will be reflected. So for the reflection, what happens? After you do the reflection, you probably will have something similar to this. So the green one is going to be your original curve. The last part, the green one is just for the negative sign. Because anytime if you have a negative sign, the graph gets reflected, right? That's what exactly you are doing. You are reflecting the graph. So once you are done with the drawing, which is the red one, we reflected the graph, which is the green one. Let's look at the steps once again. What we did. Let's look at the steps back. Step number 1. Look at here. What we did. We first just make bx minus c equals to negative pi by 2. That's what exactly we did here. Right? And for that, we found one value of x. And for b minus x minus c, bx minus c equals to pi by 2, we again solved the x. We got another value of x. Now then we said these are the 2 asymptotes, because for these 2 points of x, your y is undefined. So that's why we just pick those 2 points on the x-axis and we draw 2 parallel lines there. These 2 lines are parallel to y-axis, right? Because they are vertical lines. We basically have drawn 2 vertical lines there because of the asymptotes. Basically, we identify the x-intercept. That is the x-intercept, basically. We identify the x-intercept midway between the consecutive asymptotes. Midway means what? This is going to be the midway, right? Because we know that the graph will be intersecting here. And then we find the points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes. Now how do you get 1/4 and 1/3? Because you first have to, because these are 2 asymptotes, right? Now when you divide the asymptotes into 4 equal parts, this is going to be 1/4, and basically it is saying that you just divide the whole interval into 4 equal parts and then take the first quarter
and the third quarter. Okay, so if you start from here, this is going to be the first quarter, and from here to here, that's going to be your 3 quarter. Or for an example, if you start from here, and I don't know exactly which one you prefer better, but it's up to you. If you start from here, this is going to be your 1/4 and this is going to be your 3/4, because you are dividing the whole thing into 4 parts. Now, since you know these 2 interval points, you will know it for sure, because all you need to do is you just have to divide this by 2 and this by 2. So you know that since this is 0 and this is pi by 4, this is going to be pi by 8, right? Just divide it by 2. Divide the pi by 4 by 2 to be pi by 8. And we just did the same thing here. This is negative, that's why this is negative. Now, these points have y coordinates of negative a and positive a. Now, we know that a is, again, absolute value of a is 1, right? So these points has negative 1 as a coordinate, 1 coordinate, and positive 1 has another coordinate. So with this point, if I just add 1, so that is going to be 1 point,
and then if I include -1, that's going to be your another point. So now you have 2 points, and then what you can do is you again use step 1 to 3 to graph one full period of the function, add additional cycles to the left or right as needed. So we don't need any additional cycles at this point because we are just trying to draw the basic graph, which is here. Okay. So interesting thing is, technically people assume that from here to here this is one cycle, because one of the reasons they assume this is one cycle because of this. Because as you remember in the last class we discussed about the full cycle, and the full cycle means as soon as the cycle stops, if you start, you basically starting it over. So what happens after 90 degree, if you start just right after 90 degree, let's say 90.5 or 90.2 or whatever, the next degree is difficult to tell next degree because of the real numbers. But if we just take the next degree, it will again start from here and it will again look like this for the next 90 to, let's say this is from -90 to 90, or whatever. It's not -90, it's basically pi by 4 is 45, right? -45. So the -45 to +45, which is, what is the length? 90 degree, right? I'm saying the period is 90 degree, right? For the next 90 degree period, it will be again like that. For the next 90 degree period, it will be again like that. Okay? So you will get something like this. If the period is 90 degree, let's say if the period is 90 degree, for every 90 degree, you will see something like this. You see what I'm saying? So that's why this is one cycle, this is another cycle, this is another cycle. Because cycle means after you stop the cycle, you again will be starting over the next cycle if you just keep continuing towards that axis. Okay? That's why if you just pass that point and start taking the graph again, you will again see a similar graph. But here, remember, we have a negative sign for this example. That's why we have tried to draw the green line, which is reflected by the red line, because the red line was our original graph. But here, yeah, I think this is an example where you can see these are two different graphs. So for an example, this is one graph, and look at this. This is one cycle. So this is the next cycle. Do you think they are continuous? What do you think? They are continuous graph, just like the sine and cosine. Remember, the sine and cosine was continuous, right? These graphs are not continuous because they are not connected. Basically, they are because they are, the reason they are not connected, because at this point, this graph is undefined. Since that point is undefined, you don't know exactly where the y will be for that point, right? So that's why that's one graph, but that's not a single curve. Every cycle is like separated by two undefined asymptotes. You know what I'm saying? Because this is one asymptote. You see everywhere there is one asymptote. Now here, this graph and this graph is always different because of this. Because look at the period here. The period is starting from -pi. Period is starting at pi, right? But here the period started at -pi by 4 and period ended at pi by 4. The reason that happened because of this, because we did the math and we know how the period is found. If you do the same math here, you will get. Let's see whether we can draw these graphs. I'm saying your A. What is
A here. This is your A, which is 2, and your bx plus, bx minus c is x by 2. Let's see whether you can draw it, just to see whether you get the same graph. I'm saying the same period, just to make sure that we understand how the graph is drawn, how the period is found. Maybe you can try, I think try the next one. It will be more, try this one. Here the A is 1, right? B is also 1. The C is pi by 4. I'm sorry, C is -pi by 4.
because that's bx minus c. But you don't need to know that. You just, all you need to do is just make x plus pi by 4 equal pi by 2, and then find x, and again make the same thing, x by pi by 4 equals to negative pi by 2, and see what you get. Let me write this original equation. So here, this is your so finding the asymptotes. What do? X plus pi by 4 equals to this, and then solve it for x. And then again you will do the same, but this time you will write x plus pi by 4 equals to negative pi by 2 and solve it for x. And see what you get. You will get two asymptotes and see whether that matches these asymptotes here. Look at the asymptote here. One is negative 3 pi by 4 and another one is pi by 4. See whether you get these two values of x. And this is also interesting. Look at the midpoint. The midpoint is not the origin. Do you see that? It's not. It will not be always origin. In our case, the midpoint was origin because because in both sides we had the same point. Just the positive and negative signs are different. So that's why the midpoint was origin, but it may not be the origin. Here, look at the midpoint. You see the midpoint is here, but the origin is here. You just get the midpoint from this period. Whatever the period it is, you just divide it by 2, you get the midpoint, right? So once you solve those two asymptotes and you got the period pi by 4 and 3 pi by 4, now the first step is you divide these by 2 to get the midpoint. Now think about this. This is 45 degree, right? I have pretty much 135 degree pi by 4.
That's negative 135. So it means you can divide this into 4 parts and each part will be 45 each. This is 45, 45, 45 and 45. See what I'm saying? And this is going to be your midpoint, which is, since the origin is here and this is 45 degrees, so this is going to be minus 45, right? That is your midpoint right now. And this point is, what is this point? Negative 90, right? Because look, 45 minus 45 minus 90 minus 135. Because each small part is 45, right? Negative 45, another negative 45, another negative 45. So it's 45, 90, minus 135. So this is your midpoint, and then this is the first quarter, let's say, from here. And this is the third quarter. So what happens, you will find a point here and you will find a point here. So since you know this is your x-intercept, what will be the y-intercept? The y-intercept is going to be the a. What is a? Look at the original equation. That's 1, right? So that's why you took 1 from here. Look at this. This is 1. We took 1 from here. That's your point.
and then you take this is your third quadrant. I'm saying the third quarter here in the at the origin. You take the y-intercept. So maybe you can think like this: start from midpoint, go to the next quarter, and then just pass the next quarter, and go to the y-intercept, because the y-intercept is -1 for the negative side. And then if you go to the right side to the next quarter, and then go to the positive direction up to y-intercept, which is 1. Since this is the positive side, we go positive direction. Since this is the negative side, we go to the negative direction. So you get another 2 points here. Once you know this point and once you know the midpoint, you can add these 2 points. You can just draw the remaining part. So all you are doing is you are trying to find the interval first, and then you are trying to find the midpoint, and then using all this information, you are trying to find another 2 points based on the first quarter, third quarter, and intercept information. Once you have those 3 points, because you have 3 points, look at this. This is 1 point, this is 1 point, and this is 1 point. Once you have these 3 points and you know the asymptotes, you should be able to draw the graph. You know, your drawing will not be accurate, but most of the time you have to identify the graph from the given graphs. Let's say in the multiple choice question, you will be given like couple of different options. Let's see. Do you want to try one more? It's up to you. Let's try this one and see, because I'm not sure whether we understand it. Just let's see whether you can find the first you want to find the asymptotes. Then you want to find the midpoint. You may look at the steps how he did that. Maybe I can just write the number here. Let's say this is the step number 1, step number 2, you get the asymptotes. Step number 1 and step number 2, you get the asymptotes. And then step number 3 is here, you get the midpoint. Step number 4 is you get the other 2 points. So okay, what are the asymptotes? What are the asymptotes? 0 and pi, right? Everyone has the same answer? So 2 asymptotes, one is 0 and another one is pi. Now, let's see, once you have 0 and pi, what will be the midpoint? What is going to be the midpoint? Let's say this is, one is 0 and other one is, let's say, pi here. So the midpoint must be here, right? What will be the midpoint? Pi by 2, right? That's simple, right? So it's 0 and pi, so it's going to be pi by 4. I'm sorry, pi by 2. Now, also, that's the midpoint. We just found the midpoint. That's the middle point. Now let's draw a vertical line also here, just because this is a these are the two asymptotes. Now we got the midpoint. Now can we find one middle point between these two? What will be the midpoint between these two? That will be your first quarter maybe. What that will be? Pi by 4, right? Let's say that pi by 4. How about the midpoint between here, these 2 points? What that will be? 3 pi by 4, right? Is this right? 3 pi by 4? Okay. Now this is 3 pi by 4. So we got our midpoint too. Now we got our 3/4 3. Now this is one point for your drawing. Now what is A here? A is 1, right? So let's draw those 1, 2 points. Now when you go to the negative side, this is and then you will go to the y-intercept, right? Now the y-intercept is basically your A. Y-intercept is your A. Since you are in the negative side, because if you go to from the midpoint, if you go to the left side, that means you are going to the negative side. From the midpoint, if you are going to the right side, you are going to the positive side. Since you are going to the negative side, you go here, and then you will go to y-intercept, which is 1. And the point will be what this point will be? Pi by 4 negative 1, right? And then if you again start from midpoint, go to your right to the 3rd quarter, and then go upward up to y-intercept. Again, the y-intercept is 1. So you will probably go here, which will be, what will be the point? 3 pi by 4 comma 1, right? So you now have 3 points. You exactly need these 3 points with your asymptotes. Now what you can do is you will basically just add the 3 points and then extend the line. Remember, this line should never touch y-axis because they will never touch it, but you will go all the way to the infinity like this. Maybe it should be extremely close. It will be close, but close enough. But so just make it infinite. So just put some arrow here. Any question? I think when we understand the tangent, the cotangent is extremely simple. Look at the cotangent. Pretty much same type of curve. So you should be able to draw the cotangent because all we are doing is the same kind of step. Now the graph of cotangent is several characteristics. In general, the basic cortex, okay, that's the period is pi and domain is all near numbers except pi because the cotangent is undefined at pi. So you see the vertical asymptote is basically all integral multiples of pi. So basically 1 pi, 3 pi, 4 pi, at all of those points your cotangent will be undefined. Fine, look at this. In the pi, undefined, right? In the 2 pi, again undefined. So what it
means that by at integral multiples of pi, that means 1 pi, 2 pi, 1 pi means just pi, 2 pi, 3 pi, 4 pi, 6 pi, 5 pi, 6 pi, 7 pi. Similarly, in the negative side, negative pi, negative 2 pi, negative 3 pi, all those will be the asymptotes because on all of those points your cortex will be undefined. Okay. So what is the difference between cortex and pi and the tangent x? Because remember, in the original tangent x was undefined at every pi by 2. But this is undefined at pi. So an x-intercept occurs midway
just like the earlier one, because it's always the midpoint between two asymptotes. It's always the midpoint between each pair of consecutive asymptotes. Odd function with the origin symmetry. Why it is odd? What is the definition of odd function? Do you remember? F of minus x equals to minus f of x. Okay. That's a negative function, so that's the odd function. And again, that's symmetric about the origin, because if you just think that this is that's symmetric about the origin, so with the origin symmetry. So if you have, and also these are the two other quarter where between consecutive asymptotes have y coordinates of 1 and minus 1. The reason this is 1 and minus 1 at this point, because your A is 1 here. Do you see because that's the basic original cortex. So the A is 1. Let's say if this is 2 cortex, so this is going to be 2 and minus 2. Just like the tangent, okay? Now, to find the graph of y equal to cortex, everything will be same, just like we did for tangent, except one simple thing. Everything is same, exactly how we did for tangent, okay? One simple thing is, this is pi instead of pi by 2. Do you see the change? That's the only change we have, because tangent was undefined at pi by 2 and negative pi by 2. Compared to that, cotangent is undefined at pi and negative pi. Oh, I'm sorry, pi and 0, because that's the basic tangent, because it basically takes an interval of 180. So it again, it's also undefined at negative pi, but since we are comparing with the original cortex, so this is going to be pi and this is going to be 0. So that's the, you see, this is the only line where it is different than tangent. Every other calculation is absolutely same. Okay, every other calculation is same, except in case of tangent, we first assume that bx minus c equals to negative pi by 2, and we assume that bx minus c equals to pi by 2, and we find two values of x, and we know two asymptotes from there. And here we just assume that bx minus c equals to 0, and then we'll assume bx minus c equals to pi, and then we'll find two asymptotes. And except this line, everything else is exactly same. And the reason is because the cotangent is undefined at those 2 points. Let's try one example. Let's see which one which one is. Oh, oops! I like this one. Let's try this. What is A here? 2, right? And you see the bx plus c, right? I'm sorry, bx minus c. Let's try this one and see whether we can draw this graph. Alright, so what is the step 1 here? Step 1, we do bx minus c equals to 0, which is x plus pi over 4 equals to 0, which means x equals to negative pi by 4. So we have our first asymptote here. Step 2, bx minus c equals to pi, to get our next asymptote. So again, x plus pi over 4 equals to pi. From here, x equals to 3 pi over 4. So these are our two asymptotes here, negative side and the positive side. Let's try to see whether we can draw those two asymptotes from here first. Now, one is here, which is negative pi over 4, and the other one is here, which is, let's say, 3 pi over 4. Now what is going to be the midpoint? Do you see this is 45 degree, negative 45, and here this is 135.
So now you see this, that will be like 445 segments. There will be 445-degree segments. So the midpoint will be here, which will be pi by 4 is going to be your midpoint, right? And this is going to be the first quarter, which is origin. And the second quarter will be here, right? I'm sorry, the third quarter will be here. What this point will be? Between 45 and 135. What will be the point? This must be 90, right? Which is the third quadrant.
What is the y-intercept here? What is y-intercept? A, right? A. Y-intercept is your A, which is 2. So, you start from midpoint. So this is our midpoint here. We start from midpoint. Let's go to the negative direction. Go to the first quarter and pass one or pass one quarter, and then go to y-intercept, which is here, let's say. And then you again start from midpoint, go to the right side, pass one quarter, and then go to y-intercept, which is 2 from here, 1, 2. Now you have 3 red points. Do you see 3 red points here? Oh, okay. I'm just doing something wrong here. There's the cortex. There's the cortex. So I think we'll find a point from here, because if you go to the negative side, you go to the positive y. This is the point. And when you go to the positive side, pass one quarter and you go to the negative, because the curve will be like this. Now, since you have 3 points here, and also let's draw the asymptotes also. So let's say this is one asymptote here. This is the other asymptote. And you have 3 red points. So let's see whether we can add 3 points first. So that's going to be your curve. Alright, so here you see the cosec and sec curve. The interesting thing is cosec and sec curve can be derived from the sine and cosine. Look at here, the blue ones are the cosec curves. And interesting is, do you see the red dotted line here? That's the original sine graph. Okay. And for the same, for the same x, okay, for the same x, the red one is your sine graph,
and the blue one is the cosec graph. And there is a strong relation between sine and cosec, because sine x equals to 1 over cosec, or cosec equals to 1 over sine. So they are just like reciprocal to each other. Sine and cosec, they are reciprocal to each other, and that's why what happens, if you look at the sine graph, the red line, in every half period, just the half period, right? Half of the period. That means in every peak, either it's the positive peak or negative peak, you see there is a U-shape something, right? You see that? At every U-shape, at every peak, let's say this is the positive peak, maximum point. You see there is a U-shape and there is a U-shape. And do you see the asymptotes here? Look at this. At these 2 points, this is not defined. Similarly, here, this one, this is not defined at these 2 points. So, sine from -1 to +1, so which is, but the cosec, but what is important here to identify that once you know for a specific
x, you will be able to derive the cosec from there, because all you need to know is what is the peak. Once you know the peak, you know that there will be a U-shape, right? There is a U-shape there, and this is a reverse U-shape maybe, whatever. Reverse U-shape there. And so basically all you need to do is, when you need to draw a cosec graph, we will first draw the sine graph for that x. And to draw the sine graph, all you need is you need to know the period. Once you know the period, you'll be able to draw the sine graph. And once you draw the sine graph, then you will know what will be the cosec graph. So that's like pretty much simple compared to tangent or cotex, because drawing the sine graph is simple based on that ABC. We know how the sine graph will look like. Okay, and then from there, so we'll do some practice for sure. So and similar is true for cosec, for sec and cosec, because the sec and cosec, they are also reciprocal to each other. And that's why, as you see, the red dotted line is the the cosine graph. So, and every single peak, there is a U-shape or reverse U-shape. So, for the x, if you know what is the how the cosine graph will look like, you'll be able to find their sec graph. And interesting is, at every here, if you see at every pi by 2, here, these are the points. Whenever it intersecting the x-axis, at this point, your sec is undefined. And similarly, in the sine graph, you see, whenever the sine graph is intersecting the x-axis, those are the points where the asymptotes are going to be, because at those points, your cosec is undefined. Do you have any idea that why at this point the cosec is undefined? Any guess? What happens at this point? Because look at this. At this point, at these points, x is 0, right? Do you see that x is 0? And because of the x is 0, sine becomes 0. Now, whenever the sine is 0, if you take the reciprocal of 0, what happens? Yeah, the y equal to sine x equals to 0, yeah. What happens? Because what happens regarding the sine, for x equals to 0, sine 0 equals to 0 as well. Now, what happens in those cases? Because the y equals to 0, because y equals to sine x equals to 0, right? Now, if you take the reciprocal of 0, what happens? What is the reciprocal of 0? Undefined, because technically we assume that 0 means 0 divided by 1. Okay? Technically the 0 means this. Now if you take the reciprocal of this becomes 1 over 0, which is undefined. And that's the only point, that's the only reason so why you see that every time the curve is, whenever the curve is intersecting the x-axis,
because those are the points when y equal to 0. I'm saying that y equal to sine x equals to 0. And similarly here, y equals to cos x equals to 0. Because of that reason, at every single point like those, because the sec x is reciprocal of cos x, and that's why those are undefined, and those become the the asymptotes for those graphs. Now let's see how we can draw this. Now let's look at some of the variations. Now remember, all we will try is, we'll try to draw the sine graph for cosec, or we'll try to draw the cosine graph for sec, and the rest is simple. Once we have it, we'll know the peak. From there we'll be able to, let's see what graph it is. Let's say this graph is here using a sine graph to draw the 2 cosec. So what we are doing is, at first what we are doing is this. This is what is given to us. Okay, so we just replace the cosec by sine here. Let's say we assume that this is 2 sine 2x. I think that overlap, that the picture is overlapping the writing, but we understand that there's 2 sine x. I'm sorry, 2 sine 2x, and this is the graph for 2 sine 2x. Do you remember how to draw the 2 sine 2x? We did it yesterday. How to draw it? Just quick guess. What do we did? We have A, B, C's, right? Now in this equation we don't have C, so that means we don't have any horizontal, so just ignore it. What do we have? We have A. A is 2, right? Now from A, what do we get? Amplitude. So the amplitude is 2. Look at the peak. 2, right? Look at the peak. -2.
Because of the A equals to 2, right? Now what is B here? B is 2. What do you know from B? From B we can find period, right? Remember the equation? What was the equation? I think it was much simpler than tan x and cot x, right? What do we did? When you do this, you will know the period, right? When you do this, for an example, here the b is 2, right? So you just divide 2 pi by 2, this becomes pi. So that means your period is going to be 0 to pi. That's how we know. I'm just trying to make sure that we know how to draw the sine. We know it from the previous section. Just double checking. So that's how we know the sine. Now once we know the sine, we know the peak, and we'll be just drawing. Look at how it is changing. We'll be just drawing some U shapes at every peak of sine. It doesn't matter whether it's a maximum peak or minimum peak. Look at this. This was the peak, right? We draw a U shape there. We draw another U shape there. And every single time the graph is intersecting, the red line is intersecting the x-axis, we'll draw a vertical line there, because those are going to be the asymptotes, right? So I think it's quite simple. All you need to do is you just need to draw the sine graph. And then every single time it's intersecting the x-axis, you will just draw those vertical lines, because those are going to be the asymptotes, and then you just draw some U-shapes and reverse U-shapes at the peak. In all the peaks, you will draw these U-shapes, and all the negative peaks, you will draw the reverse U-shape. Interesting is, those blue lines here are your cosec graph, right? Because that's what you wanted to draw. But you first have drawn sine, because you want to. So basically you have drawn first the red line here to get the blue lines. And blue line is your original graph that you were looking for. Any question? So, and remember, you will always have, sometime you might have vertical shift, you might have horizontal shift in the sine graph. Once you know it from the sine graph, then you just use those U's or reverse U's for drawing the cosec. Now this is about the sec graph. Now what we did here, we first assumed that just replace the sec by cos. Now once you do it,
based on that, we'll be drawing the red one. Do you see the dotted red one? That's your cosec graph. Now, what do you know from here? What is A here? It's 3, right? A is 3, so you know the peak is 3. And from here, what do you know? What is B here? What is B? What is B here? B is half, right? You don't see the B is half? B is half, right? Look at the B here. Half times X is BX, right? So B. So how we know the period? 2 pi by half. So it's going to be 4 pi. Do you see the 4 pi here? Because, you know, the period is 4 pi, but what happens is this. You start from here. Let's say if you start from here, your cycle will complete here, right? Look at this. This is 4 pi. Because since you are starting from here, your cycle will stop here, because after this point, everything is repeated again. Do you see this is 4 pi? Now, one more thing. Do you see a negative sign here? That's why everything was reflected. The original cosine graph was this. You reflected this. Now, once you reflected, you got the red line. Now, once you have the red line, you know that every time the red line is intersecting the x-axis, you will have some vertical lines. Those are going to be your asymptotes. And then at every peak, you will be drawing the blue U's or reverse U's. And those U's are going to be your seg graph, which you are looking for. The blue graphs are the original seg graph, right? The seg graph we are looking for. But here, in this example, we just had one interesting thing was like negative sign. Because of that, it was reflected. But you will probably also have like vertical shift, horizontal shift, and all those things. Let's see what do you have. We have some exercises here. Let's see whether we can practice some. So let's see which one. So basically, they are looking for the seg graph. Now, what is reciprocal function?
There's the seg graph, right? Cos and sec are reciprocal to each other. So, here, these are all the 6 graphs we covered. Now, the first 2 graphs, the sine and cosine, we covered in the previous section. But the other 4 we covered today in this section. And let's see whether we can answer some of these questions just by looking at those. This is the graph of which function? Any guess? Okay, as the first view, it looks like that was a tangent, right? But look at the answer. There is no tangent. Oops. So there is no tangent. Now what is that? It's basically cotangent but reflected. Look at this. If the cotangent reflected, it becomes tangent. And if the tangent reflected, it looks like, look at this. That is the cotangent, okay? Oh, that was I'm sorry, that's the tangent. That's the tangent, right? But if the cotangent reflected, which that will also look like this. So that's basically number C. You see the reflected, so that means that must be preceded by a negative sign, right? That means the reflection. So it's number C. Everyone agrees that the number C is the right answer? Or any better answer? Okay, let's see whether we can do some elimination. Now, the first of all is cosec. It's not cosec for sure, but the cosec, because the cosecs are all U's, right? There is no U. Eliminate this. The last one is sec. Eliminate these because those all are U's, right? Now, it's not cotangent because the cotangent is, this looks like 10, right? Cotangent is the other way. So, you eliminated all of this. You are left with C again. Because, sometimes people do elimination, the wrong answer, elimination. How about this? Find the reciprocal cosecant or secant function for this given graph. Find the reciprocal, okay, now the graph is already given.
Now, first of all, based on the graph, just look at the graph first. And look at the question here. Question is asking either the cosec or sec. Now, can you tell me can you find cosec or sec? Which one you can find from here? Look at the original graph. What is this graph? Is this the sine graph or cosine graph? Sine, right? Since this is a sine, its reciprocal must be cosec, right? So you will always get a cosec graph. You will never get a sec graph. So now your answer must be first three. You eliminated this one because this is not going to be sec, because the original graph is sine. So now let's look at these three and see which one is this. Now, first of all of these three are preceded by 3, and we know that will be the case because here the amplitude is 3, so we don't have any issue with that. Only thing that we have to look at is this part. Now remember, if you have a cosec graph, you don't have the cosec graph here, it's basically the sine graph. The cosec graph will be the use here, right? Use or reverse use. Now, if you think it as a sine graph, you know the cosec is related to sine. This is going to be sine x, this is going to be sine 2x, and this is going to be sine 4x. Now, what you can infer from x, 2x, or 4x? You can find the period, right? Now, let's check what is the period in this one. Period is pi by 2, right? Look at the period. Do you see the pi by 2? Starting from 0 to pi by 2. Do you see the pi by 2 here? So for which one you will get the pi by 2? What do? You basically divide. This is how you get the the period, right? Now, for an example, here for this one, b is 1. If you give b is 1, it's going to be 2 pi, so that's not right. If you give b is 2, that will be pi, that's also not right. If you assume that b is 4, then it will be pi by 2, right? If b is 4, it's going to be pi by 2. So the right answer is C.
Why would the period be the whole thing? Why wouldn't it just be half and half?
What do you mean by the period by the whole thing? See, the period is the time or the degree you need to complete the cycle.
But the cycle wouldn't that be half?
No, because do you think after half is repeated? It's not repeated. It's going to the negative side, right? Look at this. You were saying that cycle started here and ended here.
No.
So you are saying the cycle is.
There and then it ended at X over.
But again, in that case, what is the period? You are starting from negative pi by 4, and you are ending at pi. That's again, it doesn't matter. That's again pi by 2. You see it?
It's pi by 2, yeah. So this pi by 2. So. See, it doesn't matter where you start. It just doesn't matter where you start. You will always get the same period. All right. So that's the end of section 1.6.